Okay, so yesterday what we did was, if you look at 18, because I kind of marked on number 18, that m, both of those m have a exponent of 1. It's understood. Okay, so I put the ones there. So 3m times 3m gave me 9m squared. Okay, so we distributed the 3m across the 3m plus 6, and then the negative 3 across that trinomial, and you combine like terms. When you combine like terms, you only add the coefficients. When you're multiplying, you add the exponents. So that's where that 6m squared came from. All right, any homework questions? Yes? Number 20. Okay, on number 20, you are asked to find the area of the shaded region. So the shaded region, so all of this is the area, everything is right here. We don't want the unshaded region. So you're taking the area of the outside, that means the whole thing, and subtracting the area of the inside. So the outside area is 4x times 3x plus 2. 4x times 3x plus 2. Minus the inside is 2x times 3x. So then I multiply these by distributing the 4x. So 4x times 3x is 12x squared. 4x times 2 is 8x. Minus, keep this in parentheses for right now, and multiply those two together, 6x squared. So that's a negative 6x squared. So combining those like terms, positive 12 and negative 6 give me the positive 6x squared plus 8x. Okay, so for today, we're going to be multiplying binomials and monomials and trinomials. It's pretty much the same. You're just going to, why did that go right back to red, didn't it? No? Okay. All you're doing is distributing. Now, before I begin this, let me tell you that I know a lot of you are going to be out on Thursday. So that re-quiz that we're going to do, we're going to wait and do that next week. Okay, because too many of you are going to be out on Thursday. Yes? I have to, people still have to take it. I have a couple of people that, where did we say how we're going to do it? Wednesday. They're going to do it tomorrow in class, and then we'll, I'll get yours back. So you should get them back Thursday. We don't, okay, you can just come by and get it from me. Okay, so your study guide for Unit 1 is on D2L. I've already recorded it. It's under Unit 1, and it says Study Guide Solutions. Okay, so you can go to that at any time. I gave you the study guides yesterday. Ashlyn, did you get a copy of the study guide? What all did you get there?
Wait, when did you get that?
I think I gave it yesterday, didn't I? Yeah, you've got it.
Okay.
All right, so you can go at any time, and because if you're going to be here Thursday, that's what we're going to be doing in class Thursdays. I'm going to let you go on D2L and check your study guide. If you're not here, then you are on your own to do that. Now, tomorrow, let's see, tomorrow, I think I have a little activity that we're going to be doing, but before we start the activity, I will go over the quiz. Because I'm going to pull the ones who are taking the quiz, I'm going to pull you into a different classroom to take the quiz while we go over the quiz. So you'll have that since you're not going to be here Thursday. All right? All right, so let's start with today. Now, when you're multiplying, just like yesterday, you're distributing. When you multiply two binomials, a binomial means there's two terms inside it. There's a special method that we can use called the FOIL method. FOIL method is just an acronym for distributing. Okay, so you have two binomials. You're going to take one term from each binomial. The first term from each, you multiply them together. The outer terms, that would be the ones on the outside, one from each binomial. The inner terms would be the ones on the inside. I'm going to show you this in a minute. And then the last would be the last for each one. So you're multiplying one from each binomial. And it's called FOIL method. Now, again, FOIL method is just an acronym that helps you to multiply these. And all we're doing is distributing. The reason I want to introduce it as FOIL method is because later on we're going to be going backwards. And if you understand FOIL method, it's going to help you to be able to factor, which is something we're going to do later. All right, here we go. First binomials. X plus 2 times x plus 4. All right, here's one binomial, here's the other. The first term in this binomial is x. What's the first term in this binomial? All right, so x times x, that's your first times first. X times X is X squared. O is for outer. What's on the outside? One from each. The X and the 4 are on the outsides. Now multiply those. What's 4 times X?
4x.
Inside, those are the ones beside each other, one from each binomial. 2 times X, those are on the inside. 2X. And what's the last term on each? What's the last one in this binomial? What's the last term in this binomial? 2 over here.
That is
So 2 times 4?
wait, 8.
8.
Look, face Lalo.
Alright, so, okay. That's the last times last. Alright, so first times first, outers, inners, last times last. Now, again, all we're doing is distributing. I'm going to show you the same thing with distributing property, and you're going to see it's the exact same thing. Do I have any like terms? Yes. Yes. 4x plus 2x is 6x. All right, that is your product. Okay, FOIL method is the same as distributing. Now watch when I do it with distributing. I'm going to take this y and I'm going to multiply it by each term in the second binomial. What's y times y?
Y squared.
Now y times 1. Y. Now we distribute the 5. 5 times y and 5 times 1. That was FOIL method. That's the same thing. First times first, outer, inner, last times last. Add these two like terms, and we're finished. That's all there is to it. All right, you try number 3. Okay, did you get k squared plus 9k plus 18?
Yes.
Okay, that's right. All right, first times first, that's k times k is k squared. Outer terms, k times 3. Inner terms, 6 times k. And then last times last. Again, FOIL method is nothing more than distributing. That's all it is. These are like terms. All right, if you understand that, then you understand everything else I'm going to be doing today. Most of it. Because all that's changing here is your signs are in different places. So just be careful about your positive and negatives when you multiply and add. I'm not going through all these examples because I really don't think you need all of them. Are you good so far?
Yes.
All right, let's go on to number 5. Okay, what's your first times first? M times M. Okay, which is, which ones are the outer ones? M and negative 7, so that's going to be negative 7M. What are the inner terms? 3 and M, which is 3M, and last times last, which is good. Most of the time, it's your outer and inner terms that combine. So that's M squared minus 4M minus 21. Are we good? Okay. Let's skip to number 11. Now, what looks different about 11?
It has 2 variables.
Yes, it has an A and a B, 2 variables. All right, so let's see how we do that. All right, so I start with 2A times A.
2A squared. No, Q.
No, you're at 2A squared, adding your exponents, 1 plus 1. Now, that's your first times first. Now, 2A times 4B. Negative 8AB. Remember, we put, if you have more than one variable, we put them in alphabetical order. Okay, now the inside would be 5B times A. And then last times last would be 5B times negative 4B. Yep. Again, your outer and inner terms are your common terms. And you only add your coefficients. So I have 2A squared, negative 8AB, and positive 5AB. are you good?
Yes.
Okay, skip to, let's see, where is it? Number 17. Try 17. Try 17 and 18. Thank you. Okay, so in 17 and 18, something canceled on each of those. Do you see the pattern? Can you give me two binomials that would also happen with? Make them up.
Y plus 8 and then
Y plus 8?
Y plus 8 and then times Y minus.
Yes, y plus 8 and y minus 8 would do that. So if your binomials look the same but they have different signs, that's going to happen, and you're going to end up with something canceling. And if you don't notice that at first and you multiply it out, no big deal. Okay, so like if I skip down to 19, my outer and inner are going to cancel. So what will my final solution be on 19? 9x squared. That and that are going to cancel, right? And then you have, yeah, so your outer and inner cancel. So if you notice that they are the same with different signs, that's called conjugates. They're conjugates. Then you can just skip doing the outer and the inner. If you don't recognize it, you just multiply it out, and then you'll get that. Okay, now I need to skip to 22. All right, do you agree that this means x times x? All right, if I have 5 squared, that means when you have a binomial squared, x plus 4 squared, that means x plus 4 times x plus 4. And then you multiply it out the way we did the others. So x times x, and then the outer 4 times x, and the inner, your outer and inner are always going to be the same if it's the same binomial. And then last times last. So now combine your like terms. Okay, you try 23. I've kind of moved a little quickly on this because I really feel like you guys get it. If I'm going too quick, please let me know. Were your outer and inner terms the same on this one? Mm-hmm. So you got 4m squared minus 10m minus 10m plus 25, which is 4m squared minus 20m. Okay, are we good? Okay, we're not going to do any more on the front. We're going to go on to the next section. Now the next section are monomials times trinomials. Is that what it says? Binomials and trinomials. All right, there is no FOIL method to this. There's no acronym for this. It's just straight up distributing. So I take my first term and I multiply by every element of the second set of parentheses, and then I take my second term and multiply it by each element. And that's all there is to it. Combine like terms and you're done. So x times x squared, x cubed. Now keep going until I get every term in that set of parentheses. X times 3x, 3x squared, right. X times negative 6. All right, now I'm finished with that x. Now go to the next term in that set, which is 4. 4 times x squared. 4 times 3x, and 4 times negative 6. And now you combine your like terms. Start with the largest exponent, X cubed, and there's not another x cubed. Okay, 3x squared and 4x squared. Negative 6x, positive 12x. And minus 24. That's all there is to it. Is one note more enough? Okay, let's pick 7. Try 7. Are you ready? Okay, we're going to start by distributing the 3x. 3x times 5x squared. Yes. 3x times 2x. And 3x times negative 6. Okay, now do the same with the positive 1. 1 times 5x squared. 1 times 2x. Yeah, 2x. And 1 times negative 6. Okay, combine your like terms. Good. All right, how many of you got that right? Okay. All right, if you didn't, did you see your mistake? All right, the last thing we're going to do is another geometric application. And it's the same as the one we had yesterday. Finding the area of the shaded region. So just like yesterday, we're going to take the outside area. I'm just going to put an O for outside. And subtract the inside area. The outside area is 9x minus 2 times 2x plus 7. And all that's grouped together, so I'm going to put some brackets around that. Now, from that, I'm going to subtract the inside. Now, when you have a monomial times a binomial, excuse me, I like to lead with the monomial. So 3x times x plus 12. You can re-lead with the x plus 12. I prefer to put the monomial first. All right, now we're going to multiply this using FOIL method or distributing, same thing. 9x times 2x. Okay, and then what's next? 9x times 7. Okay, and the next? Yep. And then? Right. Okay, I'm going to keep those grouped together. And now we're going to distribute the 3x. 3x times x. And 3x times 12.
I'm assuming the other side as well.
Some of it. We'll get to that in just a minute. All right, now there's a couple of ways I can go from here. I can combine like terms here, which is what I'm going to do, or I could go ahead and distribute the negative, then combine like terms. All right, so I'm going to combine these like terms because I see that those two are alike. So 63, wait, did I make a mistake somewhere? Oh, okay, yeah, yes, in a minute, yes. I was going to combine these and then bring that down. But if you want to, do you want to combine them all at one time?
Yes.
I think it's easier to do them all at the same time. But what that means is, what I'm going to have to do is, first of all, I got to get rid of those parentheses. So before I do that, all I'm going to do is distribute that negative. And then I can bring it all down together. I'll show you why I chose to do it this way. So all I'm doing is writing this down. Now, that 3x squared, now I have to distribute this negative 1. So that's a negative 3x squared, and then what? Minus 36x. So I had to distribute the negative 1 there. Now here's why I decided to do it that way. So now I can put these together in just one step. 18x squared and negative 3x squared. Okay, so with this, I'm going to combine the negative 4 and the negative 36 to get negative 40, and then 63 and negative 40 gives you 23x. And then minus 14. I know it's long. Okay, that's your answer. Now that second sheet, I'm sorry, odd problems. And these are for classwork. If you don't finish, then finish it for homework. I think you should be able to finish it because you have 20 minutes. So you shouldn't have homework. So the odd problems.
What about the rest? Just don't do them.
You don't have to do those. Yeah, I think y'all are following. Those are just, there's a lot of examples, and I can't edit these, so I can't take them out, so we just skip them.